function that we need to introduce because it's a reasonable working assumption. Okay? So, when it rains over the catchment, you get rain. What happens here? The rain that falls over the city, where I have no storage, then the model assumes that translates into a river flow. Where there is a storage capacity, river flow, of course, is formed only when rainfall exceeds the storage capacity. Rainfall may be, let's talk about net rainfall, okay? Let's still talk about net rainfall. Where are in a catchment typically the areas with lower water storage capacity? Of course, urbanized areas, we already mentioned them. Also, we have usually a reduced storage capacity where you have water. I mean, if it rains over the river, you have no storage capacity. If it rains over a lake, you may have storage into the lake if the lake is not full. But usually, even over a lake, you don't have an increase of storage. In any case, along the river network, we assume that there is no storage capacity, and also very close to the river network, in what are called the riparian areas, there is very reduced storage capacity. Why is that? Because the water table is close to the surface. If you look at a river cross-section, and you look at the position of the water table here, usually you get something that is very close to the water level into the river, and therefore it may be slightly lower or slightly uppery, depending on the direction of the flow. If the flow is from the river to the water table, then the surface of the water table is declining while getting away from the river. If the flow is from the water table to the river, the slope is towards the river. In any case, if it rains here, you understand, if it rains here, there is no storage capacity. If it rains here, the storage is reduced because the water table is very close to the surface. So the areas that get saturated quickly usually are the areas close to the river network. And typically also you have reduced the storage capacity at a high altitude, because high altitude means presence of rocks and therefore reduced storage. So you may have some zones close to the catchment divide. You may have some areas with reduced storage capacity. So what happens when it starts raining? You have some areas over the catchment that are either impervious, the urban areas or the rocks, or characterized by very reduced storage, and therefore they get saturated quickly. So when it starts rainfall, you have these areas with reduced storage or no storage that start producing river flow. If it continues raining, of course, the extension of the saturated areas expands. So, if it continues raining, you may get something like this. So, river flow increases because it rains over the wet. It rains over saturated soils. If it continues again raining, it may be that the whole catchment gets saturated. This is the mechanism that this model tries to reproduce. now we stop here. And I tell you next time, not tomorrow, but next Monday, we will need to get an interpretation for this graph. And understanding this graph is the key of this model. So basically, this is my fc function, depending on c. And we need to prove that the integral of this function gives to me the amount of runoff. But we will discuss about it next week.